so number 5. Particles called pi mesons are created by accelerator beams. These particles travel at 2.7 times 10 to the 8th meters per second, so about 0.9 the speed of light. They live for this long when it rests, relative to an observer, how long they viewed in the lab. Alright, so the first thing that you should have in your Y here is the fact that in the moving frame of reference, time passes slower. So in the moving frame of reference, time passes slower. Let's see. When viewed, and probably I would say, the pi mesons, I'm going to abbreviate them pi dash mes, only experience their lifetime in their frame of reference. And I would also have the overarching that the speed of light is constant in all frames of reference. That's kind of, one of the big things to remember. All right? So, those are the big things for your Y. Let's grab some equations for your how. You first would want the Lorentz transformation. And then because this one is asking about time, you would want your time relationship. So, move those, make it a little better size. That. Alright, so a couple key facts to remember here. Gamma is always greater than 1, therefore T is always greater than T naught. Right? We talked about that yesterday, I think. So, in which frame of reference is more time going to pass in our problem here? In the pi mesons frame of reference or the lab's frame of reference? Hello, are there people who are doing this problem with me, or am I just doing it on my own? Raise your hand if you're actually working on this problem. Good. Okay, so this question is for you guys. Which one does more time pass? In the moving frame of reference that is the pi mesons, or in the stationary frame of reference that is the lab? The stationary. Okay, I wanted to make sure you understood that, because if you don't understand that, it's useless to do the problem. You don't understand that more time passes in the stationary frame of reference. Then you're just throwing numbers in and your understanding is gone. So that means that the T will be for the lab and the T naught will be the pi mesons frame of reference. And so we know from our Y that in the pi mesons frame of reference, only 3.00 times 10 to the negative 8 seconds pass. So, we want the time in the lab, so T. We put in our value values for the Lorentz transformation here. 1 over the square root of 1 minus their velocity, 2.70 times 10 to the 8th meters per second, and over the speed of light, which is c, which we can look up on the back of our rubric. And we have right here 2.9979. So that's another number you might want to store in your calculator. Like I stored it in my calculator as the variable c. So on mine, I'm just going to put in the c, because I know that I already have that in my calculator, squared, and this is all times, this whole thing over, this is all times my 3.00 times 10 to the negative 8 seconds, the amount of time that passes in the pi mesons frame of reference. So then if I pull out my calculator, I can do, I'm going to actually notice that if I multiply, I can have the 3.00 on the top of my fraction. Negative 8 divided by square root 1 minus parentheses 2.78 divided by, this is where having the variable c stored in there helps me. And I get my answer. And is that what I expected? Or did I make a mistake somewhere? Did I get a longer time for the left? So the question comes down to, which is bigger? 1.3 times 10 to the negative 8 or 3.0 times 10 to the negative 8? Nope. Get rid of the negative 8s because it's in both. Which is bigger, 1.3 or 3? 3. Over twice as big, right? So could this answer be correct? No, because I'm expecting a larger number. So I must have made a calculator mistake. I know exactly what I made. If I go back up to where my calculation is, I can see that I missed my dividing key here. So I did 3 times the bottom of the fraction rather than 3 over f. So I'm going to insert division. And now I get a number bigger than 3. So now I'm happy. This was a calculator mistake. That makes a lot more sense and fits with my understanding. The more time passes in the stationary frame reference. So let's see if it's right.